Hello, and welcome to this month's live VDrug session. I am Kim Fletcher, and I am one of the Virtual Java User Group organizers. If you're here for the first time, welcome to the Virtual Java User Group. We are a global community bringing you high-quality tech talks and amazing speakers from all over the world. If you are joining us live today, please make sure to drop your comments in the chat. And if you are watching this as a recording, please make sure to join our Slack channel and drop your questions there, and we'll make sure to try and get them answered as soon as we can. Anyway, that is enough from me. I will bring on your host. So welcome, Laurentiu. It's so good to see you.
Hello. Hi, everyone. Thanks, Kim. Good to see everyone here. We have today an awesome speaker backstage with an excellent presentation. I'm very happy to see everyone here. As Kim suggested, remember you have a live chat there, so please leave your comments and questions in the live chat. We want to see as much interactivity as possible. Fortunately for me, I don't really have to introduce our speaker a lot because you all know him. He's well known in the Java community. Vlad Mihalcea, he's a Java champion. He is a consultant. He's a magician. He's everything. So Vlad, thank you very much for joining us. What are you going to teach us today?
Oh, thank you very much, Laurentiu, for the introduction, and Kim for organizing this session. Today, I want to talk to you about a problem that I've been bumping onto it for many times throughout my career, and why I think it's nice to participate in this session is because we are going to go through all sorts of technologies that are very popular in Java. So whether you will find your favorite technology there or some technology that you wanted to see how it performs or how it can solve a real-life problem, I think that's going to be the chance that you can take.
Thank you so much, Vlad. Then the stage is yours.
Okay, thank you very much. 1 second. So, as I mentioned earlier, today I want to talk about this presentation is going to be in the universe of Spring persistence. And 1 second to go directly to the problem. I'm not sure how often did you see this error message or this banner on the Stack Overflow website when you wanted to find an answer to a question. But from time to time, if you are like a top level user, or if you are like a fan of Stack Overflow and visit it frequently, you would see this banner from time to time, which was saying that the website is in read-only mode. And the reason why they were displaying this banner was because of the architecture that they were using at the time, which required them to take the website in read-only mode, and you'd still be able to read Stack Overflow. It was just that you couldn't do any modifications, like ask a question or write an answer or write a comment or upvote or something like that. And this is something very interesting if you think about it, to have a system that allows you to operate in read-only mode while you are doing all sorts of changes to the software or maybe to some parts of the architecture that you are using. And the reason why they were employing this strategy was because they were having for Stack Overflow, although the website was, or the application, the web application, it was not just a website, was accessed 24/7 by people all over the globe. It was using just 2 SQL Server nodes. And the reason why this was possible is because they were using a lot of RAM, read access memory, and which was storing like half. That could store like half of the database in memory. But the problem is when you have something like this, when you have only 2 servers and you need to upgrade SQL Server from, let's say, 2016 to 2019 or something like that, you need to take it offline. And to be able to take it offline without losing availability, you needed to have something else in order to be able to work in read-only mode. And what was interesting at Stack Overflow at the time was that the architecture they were using was very simple, actually. And for performance engineers, it was something that was very interesting to read about, because it was very simple, yet it was serving the entire world. And it was doing that in a very short, the average response time was very low. And they were documenting everything about what they were doing. So it was very nice. It was something that what they were doing there was very, very nice at the time. And if you go to Nick Craver, actually was doing a lot of the infrastructure part. If you read on his blogs, you would see that they were using all sort of caches as well. So besides SQL Server, they were also having this like a first level cache in the web servers, and then they were also using Redis to serve traffic. So when they were switching from the read-write mode to read-only mode, they could serve the entire content either from the web server cache or from Redis, from the Redis servers. And that's interesting. And let's say that we also have an application and we want to do something like that. Let's say that I want to have a mode, a read-only mode, where I could serve the read-only traffic. So I could still be able to let users read my application while I'm doing something else, while I'm doing some things like upgrading my database, or maybe doing some changes to the hardware, or deploying to some switching or some cloud instances or something like that. So let's say that I have an application like this one, and I have several tables, and I have like a post, and the post has comments. I'm very often using this example because it's so easy to understand. And also the post can have tags. This is very similar to how the model is also in Stack Overflow. You also have votes, so you can do upvotes for the comments. And then you, of course, have users that do those votes. So if you take a look, there is a lot of information. My root is the post, and I have comments, I have tags. I want to fetch all that. When I'm fetching, in order to, if I want to store this aggregate in Redis, it has to be fully initialized. So I need something. I need some strategies, or I need, depending on what technology I'm going to use, I need to choose some strategies in order to fulfill this requirement that I have. And for this, I have this repository. You can scan it if you want. And we are going to go through all the, I would say, the most popular technologies that you have in Java to see which one works or performs the best. So we are going to see JdbcTemplate, Spring Data JDBC, Spring Data JPA. This one is very popular if you're using Spring Boot because it comes it comes by default. Then we have another flavor of JdbcTemplate that basically mimics what I'm doing in Spring Data JPA. We of course have JOOQ, which is also very popular, and we also have Blaze Persistence, a lesser known, I would say, plugin for JPA and Hibernate, but very, very useful. So let's start with the first one, with the JdbcTemplate. So I'm going to skip. I'm going to jump from the slides to IntelliJ IDEA. And here you'll see that, first of all, this is the repository that I talked to you about. Everything that I'm going to show you, you can replicate it if you want. Also, I'm not sure if Laurentiu told you, if you have any questions, just write the questions on YouTube or where you are where you are basically viewing this this live stream, because I'm going to do my best to answer while I'm also doing this presentation, so we can make it interactive. So one of the first and the simplest choice is to use JdbcTemplate because it just comes with the Spring framework. And what options I have. So one option when using JdbcTemplate, what if I'm fetching everything with a single query? Ideally, you would say that if you can do something in a single query, that would be great. Why do it in multiple queries when you could just run a single query and get everything that you need? And if you have to optimize it, there's just one query to optimize. Unfortunately, this is not a very good solution, but it's still something that you can try. So in this case, if I join the post with comments, with the votes, users, tags, and fetch, and of course I'm going to limit how many of those posts I'm going to fetch from the database. But if I try to do something like that, you are going to see that it's going to take a lot of time. Now, this is from JMH. So in this repository, if you want, you have benchmarks for all these use cases. That's where I got. So you can replicate everything that I'm showing you. So why it takes so long? So if I'm trying this option, of course, if I attempt to do this, I'm not going to be happy about it because this is very slow. So the reason why it's slow is because if I limit the number of posts to 50, the number of records that are being extracted and sent over the network to my application is going to be multiplied by the number of tables and records that I have there. So in this case, it's very easy to just go and have a huge result set in the end. So from this one is 50, and then I multiply with the comments 1000, and then I multiply with the users 5000, and then the tags, and so easily I can get 100,000 records that I have to extract. Maybe they are not even in memory. Extract from the disk, send them over the network to the application, and then from the application construct objects, and then even more, send that construct maybe a JSON and send it to the browser, where the browser will pick 50 and then just throw everything away. So that's not going to work very nicely. That's why it also takes so long. Now, JdbcTemplate, it's a very simple technology, but I would say that most of the time developers are choosing Spring Data something, JDBC, JPA, maybe JOOQ, or some other technology that builds on top of JDBC, or maybe it's even using JdbcTemplate if it's the case with Spring. So let's take Spring Data JDBC. In Spring Data JDBC, the default option, it's also not very performant. So let's go to see exactly how it looks like. So that was the one with the Cartesian.
So, Vlad, sorry to interrupt you. Before you continue, we have a question, and that's about pagination. So in case you have pagination, this kind of eager fetching is better. Is that okay?
So if you're having pagination, and let's say that you're using the Spring Data pagination, and the Spring Data and the query itself, maybe it's using in Spring Data JPA, maybe it's using fetch type eager or something like that, it's still not going to work. First of all, the SQL level pagination will just truncate the product, the entire product. It will, if you truncate to 50 and you have 20 comments and then you have 20 tags, it will just truncate at 50. So maybe you will get a post with maybe some comments and just a partial set of tags. So that's not what you want, because in the end, what you want is 50 posts with whatever comments and whatever tags they have. So if you're just doing the plain pagination, the SQL level pagination, just adding a limit at the end after the Cartesian product, you will limit the result set, but what you get out of the result set is not going to be very meaningful, because maybe you don't even get all the comments. So if you have 100 comments, you'll just get a truncated list of only a subset of comments and no tags, because you truncated before creating the result set, because the result set will multiply, and then you are going to repeat the posts, repeat the comments, repeat the tags in order to have everything multiplied and combined in a Cartesian product. So in this case, it will be indeed faster, but it's not going to be useful for you. Make sense?
I think so. So thank you very much. We also have a comment from Simon claiming that he likes JOOQ multiset for this. What do you think about that?
Yeah, we are going to talk about that. We're going to, if you like that, that's great, because I'm going to show you not one, two solutions also with JOOQ. So in this case, we have we had this one. We can skip over this one. So we have the Spring Data JDBC. In Spring Data JDBC, what's nice about it is that it takes an approach that is very, very similar to Spring Data JPA. You have like something like entities, although they're not entities. But they are also not just plain DTOs, because you see, you have a way to set collections, and then you can bring more than just the post. So I could use mapped collection for the comments, and then for the tags, and for the comments, I have another map collection for the user votes. It looks very nice when you think about it. But then if I try to do that, it's going to work very slow. And it works slow not because of a Cartesian product. In this case, it's because it fires a lot of queries. So this is like a typical n+1 query issue. That's why it takes so long. So actually, we can run this one. I can run it in debug mode, and then we can check on the console. So although it's, if there's only one thing that you will get out of this presentation in the end, is to just check the logs. So whatever technology you're using, Java, .NET, JavaScript, which generates statements on your behalf, always check the SQL logs that are generated, because that's the only way you can tell whether a feature works nicely or not. So in this case, you will see that if you scroll here, you'll see that there are so many queries that were executed, and we can see that actually they were 1,102 queries. And that you have like right now we have two very bad issues. One is using a Cartesian product takes a very long time, and then doing an n+1 query issue, which also takes a very long time. So these two, the first two things that I tried, are something that you always want to avoid. So okay, this is not good. But what if I have some other solutions? And what's nice in Spring Data JDBC, if you've been following it, at some point, you see in 2023, Jens Schauder wrote this blog post that they have a solution for the n+1 query problem, and they have this feature, single query loading. So let's give that a try as well. So by default, what I showed you already, that was the default. So in order to activate the single query loading, you will have to configure it explicitly. So we are going to do that. And this single query loading works with find all by ID, find by ID, find one, with some methods. However, we cannot use this feature to fetch everything, because it has some limitations. So we can only use it to fetch the post tag, and the post comments. We cannot use it for nested collections. So what it means that, let me go back to this example. So here it means that my post this time has the comments, but you see it has a transient for the votes. I cannot fetch the votes as well. And also this one has the post tag, but it cannot extract like it only extracts the IDs, but I don't need the ID. I need the name of the associated tag. And in order to solve this problem, I just have to do something else. So I can use the single query loading, but it's not going to be enough in my case. So in this case, I will have to do that, and then there are going to be additional queries in order to fetch the rest. So I'm going to use this custom repository, where basically I'm fetching everything that I can with the single query loading, and then I'm just going to append what's not there anymore. The nice thing about this, so let's run it in debug mode, because that's going to be nice. You will see that with 3 queries, you get, I would say, all the data that we wanted to get in order to store it in the cache. And you will see that this is actually, it's an improvement. It's a huge improvement over the previous 2 solutions that we had. So let's run it. And yeah, you see we have the posts, and the posts have comments, and the comments have votes, and the votes you see here they have the comment ID. Actually, I could fetch the user, but for that I need to do additional things. But anyway, this is not bad. So I have the post ID, I even have the tag name. So I have quite a lot of information. What's nice about this solution is that you see now that it's one query, two queries, and this is the other query. So it managed to do all that here with 3 queries. So it works actually quite nicely, because when you check the JMH performance test, you'll see that it manages to extract this information that we want in 21 milliseconds. Now, of course, it doesn't fetch everything that the other that you will see are going to fetch, because the other ones can also fetch the users and additional information, but still, it's still very fast. 21 milliseconds to fetch that from 400 milliseconds, that's quite an improvement.
So a couple more questions, Vlad. We
Yeah.
have, George here says, I saw a lot of people using entity graph and a lot of attributes paths for this. What do you think about this approach?
Well, actually, you could make it work somehow with that. I tend to, as you will see, we have a solution for Spring Data JPA, which is actually more readable, more easier to understand, and it performs great actually. And it performs great because it uses the same strategy that otherwise you would do with just plain JDBC actually. So while, yeah, you can use that, you are much more limited using entity graphs. So the solution for Spring Data JPA, this one is what you would get by default if you were using Spring Boot. So what you need to do, of course, you don't want to do a Cartesian product. Luckily, if you have lists, Hibernate doesn't even let you do that, because you will get the multiple backfetch exception. So you can do all that with 3 queries actually. And these 3 queries, what you have to do in order to fetch all this information is just have a service method which defines the transactional boundaries. It can be a transactional read-only, because we're only reading data. And whenever you're using read-only, you just discard the flush part, so there's no flushing, so it's much more efficient anyway. So what we need to do is we can only fetch one collection per query. So we can fetch the post with the comments, and now the tags are proxies. But because they are in the same transactional context, the entity manager will then reuse the post that I fetched. So if I try to fetch the post with the tags, is when it gets the result set and it tries to create and bind the post to the persistence context, it will see that there is already a post. So it will reuse the post, and you just replace the tag proxy with the actual tag collection. So this one basically just does a progressive fetching, and it merges everything nicely, not only on the post, but also on the comments. If I fetch the comments with the votes, the comments that were fetched here will have the votes attached. You cannot see this in debug, because the debug mode will trigger the initializations, but you can see it with logs very easily. And this solution works like this. So this is the query. The first one fetches the post and the comments. Now I have the post and the comments. This one fetches the post and the tags. It will append the tags. And now I'm fetching the comments with votes and users. And this one works in 23 milliseconds. You will see, compared to the other methods, this is almost as fast as everything else, with all the convenience of Spring Data JPA. Now, what you can see here, that any technology in itself, you can use it to get like excellent performance or bad performance with any of those technologies. It's just up to you how you're using it. So let's see how this one works. So let me basically go back here. Let's close what we don't use. So let's get the Spring Data JPA with multiple queries. Yeah, that's the one. If I would try to do that, it would not work. I would get this multiple backfetch exception. So no need to do that. But here, this is what we're doing. We have a transactional service method that just fetches the post with the comments, and then the post with the tags, and then it just fetches the comments with the votes. That's basically it. And when we are running this, you will see that I get everything nicely fetched with Spring Data JPA, and it doesn't even take a very long time. Actually, the response time, it's, as you will see, compared to the other solutions that I'm going to show you, it's very similar. It's very, very similar. The difference is going to be insignificant, actually. And you can even optimize it even more. I haven't even added optimize it at database level here, and it still works pretty fast. So here I get a post, as you can see, with comments, and the comments have the votes, and the votes even have the users, which the single query loader didn't have. So I actually fetch even more than Spring Data JDBC, and it works very, very nicely. Again, you have all the tests here. You have the performance test. You can run it. If you don't believe me, you can just run it and see for yourself.
One more question from Kumar,
yes, sure.
Vlad. So it's a more specific question about single query loading. So Kumar says that it only supports find all and find by ID. So how can we use it for n+1 in this case?
So if the n+1 is for instance, you have find all, but then you can specify you can specify like a filtering criteria. Like if you're doing exactly like as I did here, where you fetch some entities, where you have find all some entities, but you have a specification or you have a filtering criteria that limits, of course, not fetch the entire database table from the database, then it will work. But it won't work for things that are much more complex, that require subqueries or other things. So it's a solution that it's limited to an example that it's similar to what I'm showing you here, but it's very limited actually. While the other solutions are not as limited, they're actually quite flexible. So yeah, that's something that if you're heavily invested in Spring Data JPA, then you have a solution. Otherwise, if you are not using Spring Data, if you're heavily investing in Spring Data JDBC and you already have it, then you might consider using it. But if you have other technologies which work great, you have other alternatives that work just as fast, and they are much more powerful, actually. So I hope that it answered your question. Now, I ran this presentation for the Dev Bulgaria community, and someone actually asked me at the time a very good question, and that person said, what if we're doing what Spring Data JPA did with JdbcTemplate? And that was a great question. I didn't have the example at the time, but then I built it because that's a very nice example. So what if we take this approach? Because what we did with Spring Data JPA, you could basically do the same with JdbcTemplate, and we have seen that it worked fast with Spring Data JPA. Why not apply the same approach? So actually we can do that. So we can use and do something like this. So in JdbcTemplate, we have a query that fetches the post and the tags. And then we have to, of course, have like a row mapper that transforms from the result set to the actual object that we are fetching. And then we have another query that fetches the comments with the votes. And if we combine all those actually with two queries, and you will get exactly the same information that we want. We can run it here, so you can see that it works just fine. And not only that it works just fine, it's going to be very fast. The only downside is that you have to write those row mappers. Now, previously, before Claude Code and AI, you would have to do it manually, and it would be verbose, but you would have to write all those verbose things. Now, it's no longer the case. I would say that things like JdbcTemplate, with all its verbosity, now if AI does all that part on my behalf, it's not actually that bad anymore. So look here, post, I fetched the comments, and the comments had the votes, and the votes had even the user, and the tags had here all the information. So, and that was done only with JDBC, and it's not even a lot of things that I've done there. And when you take a look at performance, like 13 milliseconds, this was the fastest. Actually, this is the fastest possible Well, this is the fastest that I got. I didn't get to anything else that matches this. So this is, I would say, a quite nice solution because it fetches everything that I need as fast as possible, and it's not even very hard to write. Of course, previously I would say that, oh, but you have to do it. If I have to do it for 100 use cases, I would have to do all those raw mappers. But now with AI can do it. I can just have to write the proper prompt for it. JOOQ, someone said about JOOQ. Of course, we have JOOQ. Now, JOOQ has this multiset, and it was in a question. It's been here, it's been in JOOQ since 2021. Lucas Eder is the first one who popularized it because it's not something that was not known before. It was known, actually. If you take a look on the forum for Blaze persistence, there was a discussion even 2016, 2017 about it. So it was mentioned. People, I would say, knew about it, but it was not popularized. It was not provided in a framework that would work on multiple databases. We offer a solution in multiple databases. So this solution with JOOQ multiset is not bad. It's like 50 milliseconds. Let me show you how it looks like. So in this case, if we go to JOOQ multiset, so this multiset works something like this. So you select the post, and then for every collection you'll do a multiset, which behind the scenes will just do the query and then write, instead of doing a Cartesian product, write the subquery in a JSON array, because then you can avoid the Cartesian product, because an array is just one column value that you can just add to your post. So you have one for the comments and votes and another one for the tags. So that's the query that you would write. Now, again, AI can write all that for you. You don't even have to do it. It's amazing how it can generate all that like in 1 or 2 minutes, and you don't have to do it yourself. The only downside is that, so let's run it to see how it works. The only downside is that this is relative to how well your database can basically work or basically process the query that the JSON related query functions that you have to aggregate all that information. So it's relative to, that's why it takes, if you run this probably on, I don't know, maybe on Oracle or maybe or some newer PostgreSQL or something like that, maybe it works faster than on this database that I was running. But again, you have all the information properly fetched from there, and it takes, in this case, 50 milliseconds. So it's not that bad, but it's still slightly takes longer than the previous solutions. However, you also have the solution with multiple queries, which works faster than Spring Data JPA, just slightly slower than JdbcTemplate, but it's to be expected, actually. Every time you're building on top of a technology that is very low level, like we have Java, and then we have assembly. So you can do things in assembly or in C, which are faster than in Java, because there's a slight overhead for using Java over using just plain assembly. So in this case, you also have this option, JOOQ with multiple queries. I wanted to show you this because I didn't want you to draw the wrong conclusion here, as I renamed the tables here. So here you can see that you can do multiple queries in the same way. You can have multiple queries and you can fetch everything with multiple queries, and it's going to work just as fast as the other method. So that's what you want to get, no matter what technology you have. Spring Data JPA, JOOQ, JdbcTemplate, you have the option of choosing a strategy which works fast or fast enough for your use cases. Now, 20 milliseconds, it's not bad. That was the average response time, even for loading a page in Stack Overflow at the time. It's not bad at all. So yeah, this one works very, very nicely. And you get this information. All right, so we covered that part as well. The last one which we have is with Blaze persistence, because Blaze persistence also has support for multiset. This one was added in 2020. after JOOQ. It was, of course, inspired by JOOQ as well. And it's been for almost, actually 6 years already. And in order to use it, this one is available when you're fetching not entities like DTOs, which was also the case with JdbcTemplate. So you can use this multiset for the collections, and then this is the query that you're writing. So basically, give me the posts between those, the minimum ID, the maximum ID, but because you have all this information about the mapping stored in those entity views, this is everything that you need to write. You have this example here. It's this Blaze persistence demo. And here you can see that we have these post comments with tags. So you have the post view with ID and title, but it has the comments and the tags using multiset, and the comment also has a multiset for the votes. And you can fetch all that, which is going to just take the same approach as JOOQ using multiset. So the query is basically, it's very similar, but it's not the same. But for some very weird reason, it's slightly faster, at least in this version and on this database that I'm running, than JOOQ, which was the original one who created it. So you can see that you get all the information here nicely fetched. So user, you have the votes, you have the user, and then you have the tags. And when you check it out, you'll see that this one takes 23.9 milliseconds. And these are all of them. So the one which you want to avoid are, of course, Cartesian product and n+1. No matter the technology, if you're doing that, that's not going to work very nicely. It's going to take a very long time. But the other solutions are nice. They work quite fast. In fact, the last 4, they are just a few milliseconds apart. If you take a look, they're too small to see the difference, but they are they're clustering towards just a few milliseconds in between. Now, if you're curious what was the case with the multiset, I was also curious myself. I actually took the queries there. So basically, these are the
Vlad,
yes.
Someone commented. So in general, the idea to avoid row explosion is to do small mini fetch steps. Is that summarizing well?
Well, not small mini steps. So in order to, you can avoid the row explosion of the Cartesian product either by aggregating using multiset, exactly as you see on the screen, because you have this JSON aggregation that aggregates the subquery result set into an array containing the information, and this one avoids the Cartesian product. Or not fragments, I would say, if you have n relations, so if I need to fetch posts with comments and tags, I could do 2 queries. So it's like n-1 relations. So you need n-1 queries, but not small queries, just n-1 queries, just one collection on one relation, or not necessarily a single relation, because you can fetch in a single query the posts with the comments and the votes, because they can be traversed directly. So if you go from the root, you can go to the lowest level. If you can traverse through foreign key, then you can do a single query. But then if you add another such relation that cannot be linked to the other subset, then you need another query. So you need like a sibling collection. So for as many siblings as you have, you need an extra query.
We also have someone commenting about JOOQ, that it provides a private DSL for this case. However, it is difficult to learn and really need not to learn it. What is your opinion?
So let's go back to this repository. This is the DSL. So basically, I wouldn't say that you have to really learn it, because it's just SQL. It looks exactly like SQL. So it's like select from, and you have the columns, and then left join, where, order by. So let's go back to the one which was a little bit slightly more complex, which was doing the multiset. But if you take the select inside the multiset, the one that it just transformed the result set, this is like the Postgres operator where it takes the result set and it transforms into a JSON. So it's similar to that. So you can see that the query itself, it just follows the SQL standard. So if you are familiar with SQL, and learning SQL is one of the greatest advantage that, it's a great return of investment, because you're going to reuse that for many times in the future, because a lot of database technology use it. So you can, if you learn like window functions, common table expressions, and JSON functions in Postgres, and then you move to MySQL, they are almost the same. And then you move to Oracle, they are almost the same. Move to SQL Server, they are there as well, because they are part of the standard. JSON is part of the standard now in the SQL standard. And not only that, but you have it in Google Spanner, you have it in JOOQ by DB, even in new SQL databases. So learning SQL is actually very useful. Now, here, you don't even have to write this, actually. Just tell Claude that what you want to fetch, and it will write both the SQL query and it will write also the JOOQ query for you. You don't even have to do it. It knows the API because it's available. It's public. It has access to the API, and it can write all these queries for you. Yeah. So like you're like 1 or 2 minutes away from writing a very complex query like this. You don't even have to. You just have to tell what you want. You have to know which solutions work and to be able to determine how they perform in order to choose the right one which works. So you still have to understand. So going back to what I was telling you, the reason why this is the query for JOOQ, and this is the plan for JOOQ, and this is the query for Blaze, and this is the plan for Blaze. The only difference here is that in the case of they are against on the same database, the only difference is this one does a nested loop left join, and this one does a nested loop without the join, and it materializes the join. That's the only difference in between them. And it might be that on some other database like SQL Server or MySQL or Oracle, there might not even be a difference in between them. So the only way to determine is to check the execution plan to see exactly why one executes longer than the other. But you can see here that this one, even in this case, took 54 milliseconds. This one 33 milliseconds. So that's basically, those are the options that you have in the end. You have a lot of technologies, but then with all those technologies, you can apply the right approach and get good performance. So we got good performance using JdbcTemplate. We got good performance using Spring Data JPA. We got good performance using JOOQ, applying the same multi-query approach. We also used multiset, which was slightly, for this particular case, was slightly less efficient. But there are also other use cases where it could be more efficient if it involves maybe less records or something like that. So you will have to give it a try. To if they are comparable, then you could use either one or the other. What's important to know is that in order to determine which one or how they work, you have to log the SQL statements to see that. And also, if you really want to check how they perform, as I did here, I didn't just do like 1 or 5 iterations. In fact, for this particular use case, I'm using JMH for that, and I'm using here a warm-up with 25 iterations that take 1 second per iteration just to warm it up. And then I'm using 50 iterations that are going to be measurable for another 1 second. And I'm taking the average time, and I have also the confidence interval levels there. So you'll get a good impression of how it performed one to the other. Of course, not the absolute value, like 20 milliseconds, doesn't tell you anything. 20 milliseconds is just for this particular database, for this data set, and for this hardware. If you on in the production, you have much hardware which is much more powerful, or different database and larger results, that you'll get different values. But if you compare apples to apples, like the same hardware, the same thing, then you can get some you can get some you can get a little bit of an understanding how one solution compares to the other. But you can do that. It's even these benchmarks are very easy to set up in Java. That's great about Java, that you have, for every requirement that you have either something that was provided by the Java architects, or by the huge ecosystem of frameworks that are available.
Vlad, we have a few more questions
Sure,
from,
let's do that.
from our viewers here. So, not all methods will support sequential data reading, right? Use case could be a batch operation, such as exporting, etc.
So if you're doing exporting, now in the case of exporting, that's even easier, because there is a way in which you can export without even having to send everything to the client. If you have like an infrastructure where you could use the copy in Postgres, you can even export from the query directly to a CSV file, and then having a pipeline where you extract the CSV file and then you process in your ETL processing jobs. So you can do that on a replica node, and that will work. It doesn't have to go in a stream fashion as JDBC does, and you don't have to pay the overhead over the network, because it will write just page by page, block by block, not record by record. So if you can use that, if you have like a system that is similar to what Stack Overflow had at the time, where you are managing your own infrastructure, you have your own I would say private data center, then yeah, you can do that. If you're in the cloud, probably it's much more complex to do that, but it's an option. It depends on what you're using there. But yeah, I've been using it as well. It also works when exporting, but it also works when in importing. Actually, importing huge volumes of data, you can use copy. You just give the CSV files, and it's blazing fast. It's much faster than almost any technology, even plain JDBC. I have a talk about that I'm going to give next week at the local conference here in Cluj, which is exactly on this topic.
Someone is asking you about the relationship with NoSQL. So are these issues that you presented related strategies to address them, also applicable to NoSQL storage systems?
It depends on the NoSQL. Now, NoSQL is an umbrella term that includes a lot of technologies. So you can have MongoDB with document stores, even Redis, which is more like a cache. It was basically included in NoSQL. You had Elasticsearch, which was also something like NoSQL, although it was full text search. And of course, you have Cassandra, which is column-based, but then you have SQL Server, which also have column-based tables. So I would say that this applies to the document store, to MongoDB. And in the case of MongoDB, of course, you don't have that, because you can load the document, and the document can have, because it's a JSON, it can have collections already stored inside that particular document. So you don't need to do the joins, or don't need to do that. So this problem is fixed by the approach that it takes. But then it has some other problems, because by storing everything in its own table, it moves the responsibility of thinking of how you want to serve and combine the data at application development time, where right from the very beginning, when you design your documents or the collections that you have in MongoDB, it's very hard to know how the features will evolve over time in 1, 2, 3, 5, 10 years from now. And with relational databases, you don't have to, you don't have this limitation, because you just you normalize the entire schema. You have everything nicely normalized, and then if you want a very specific query, you just do the right joins or write the proper query, and then it will work. So you have the flexibility. So I would say that you don't have this problem, but you have other problems.
Yeah, sounds realistic. Now, someone is asking you about how you calculate the benchmark for the results of your queries.
Yeah, let's go back there. So you mean like in terms of whether I'm using the average or
are you using a custom code, or are you using an utility?
It's basic. No, it's not. It's being provided already. It's the Open JDK. It's Java Measurement Harness or something like that. It's JMH. It's JMH, which is basically the framework for running any benchmarks in Java. It's the standard for running any type of benchmarks. So I'm using JMH. It's not something that it's not although you can very easily write your own custom benchmark, which does exactly the same thing, does the warm-ups, and then does a lot of iterations, and then you can take the average, and then you can take percentiles, whether you want to see if there are use cases where you have like long tail or something like that. But here in this case, it's not relevant. We wanted to compare one approach to the other. So here it's perfectly fine to use the average. Where average is not enough is when you have a live production system where you also have like a service level agreement on the 99 percentile, 99.9 percentile, where you want to make sure that not only that on the average it works nicely, it's like 99.99% of the time it works very nicely, and only in very, very rare occasions it might not work as we wrote in the service level agreement that it will work. So I'm using a standard test, actually. This is standard.
So
basically,
I guess
it's not something that I invented. It's just standard benchmark with Java.
That's probably covering also the question from George, who's asking about how you get the number of queries. So is it Hibernate statistics?
The number of queries, that's a very, very interesting question. It's important. For the number of queries, now when there are 1, 2, 3 queries, you can see them in the log, but it was the question, it was relevant for this one here, for the default with Spring Data JDBC, where I had 1001, and for that I'm using data source proxy. Actually, I build on top of data source proxy. This is from Data Source Proxy. Data Source Proxy, it's an open source framework that allows you to create a proxy for the data source and then intercept whatever happens with JDBC. And that was designed, the main goal was to log properly the queries. However, you can also do other things like counting during testing how many statements are generated, and then you can validate how many selects, insert, updates, deletes you have for your integration tests. I use that all the time when I want to, and I whenever I'm implementing a feature, I do that because I don't want someone in the future play with the mapping or something like that, and then have like a hidden n+1. And when I say someone, I'm not even I don't mean a person. Now it's also AI. I don't want AI to mess my application by doing something very clever about the mappings just to fix a given issue, because the problem is that nowadays it's even much more of a problem. So you can use AI confidently if you have enough tests and enough linters to watch your back. And when I say linters, it can be any linter, like this one. This one is a linter. It counts how many statements are actually executed. I have something similar. It's called Hypersistence Optimizer, which is also linter. It checks the mappings, the configuration, whatever happens at runtime in JPA and Hibernate. So if you have this kind of safety checks, then whether it's a human or a machine doing something that you don't want, then you have someone else watching over what happens. And I think that's very important if you're using AI.
I see that people in the comments actually love a lot the hypersystem optimizer. So
yeah, I'm glad. I'm glad you do that.
And the question from myself, Vlad, if you allow me. So
Sure.
I know you actually wrote a book about high performance Java persistence. All these things that you have discussed today, can we find them also in your book?
Well, unfortunately not, because the book was written like a decade ago, and these things, as I mentioned in the presentation, emerged in 2019, 2020. I wanted to write the second edition. Last year, I wrote like 25-30% of it, but then I switched to publishing a new course, the high performance Spring persistence, and that took me very busy. And now I'm busy writing some scientific articles because I enrolled myself in a PhD program. So I promise that I'm going to publish the second edition, but I have to sort some things,
We are looking
sort some
forward to
things
that, of
out.
course.
Exactly.
We're looking
I
forward to
have
that.
this
Thank you very much.
tendency of enrolling myself in more than I can I can humanly do, and I eventually will write it, but then a lot of things are also included in some other things. So if it's not, there's a lot of good things that are like evergreen written in the book that are not only that are relevant today, they will be relevant even 10 years from now, because the book is just about the approach. It's the same approach that I included in this presentation. I run tests, check the logs, see how they work. For this version, it works like this. And a lot of things are still the same in Hibernate because it's very hard to fundamentally change it. There are all sorts of things that keep on changing, but I would say that 90% is basically the same.
Yeah, that's basically why I was asking, because I've read the book myself and I do recommend it, even if it looks older. A very large part of it is evergreen. So don't always look at the age of a book, because the contents might be relevant even a decade after it has been written. So
Exactly.
thank you very much for that, Vlad.
Yeah, especially if you're reading some ancient Greek philosophy, don't expect the second edition because the original is still relevant. Plato will not write the second edition. And the first one, it's really good, and it will be good 10,000 years from now on, still the same. Also, you're welcome.
Thank you very much, Vlad. Thank you very much, everyone, for being here with us today. Remember to join the community. And if you weren't here with us live, you can still reach us out on social media. Hi, Kim, again.
Thanks, everyone.
Hello. Yeah, you stole my words. I was going to say the exact same thing. But yes, thank you to both of you for that great session. And thanks for everyone who joined us live. Again, if you're watching this as a recording and you do have questions, do drop them in the Slack channels or contact us on any of the socials. And do keep an eye on our Luma page for future events. So thank you so much. We'll see you all soon.
And sending us our love.
Bye.
Thank you.